Hello friends, welcome to the quantum computing world. So my dear friends, as you can see the heading towards quantum computing. So in this session, we will majorly try to understand what is the need of quantum computing, what is the benefit of quantum computing, and how the researcher has reached towards the quantum computing. And after that, once the session will start, after that we will try to understand in depth knowledge of each and everything inside the quantum computing. So my dear friends, I hope in computer science, like being a computer science student, I hope all of you know what exactly all the computer science students or the researcher are fighting for. Either you are dealing with the subject operating system, or it is a programming language, or it is a TOC, whatever the subject you are studying, what exactly our target is to optimize the time complexity. And due to this optimization, the many more computing device was evolved. So starting with the simple algorithm where we basically use the CPU, central processing unit, which is the part of operating system. Hope all of you people are very much aware of this particular term CPU, which is the part of operating system, whose responsibility is to compute the instruction, set of instruction that we are supplying. So whenever, like, take an example, suppose you are given a simple problem, write an algorithm to find whether the given input is prime or not, or whether a given number is prime or not. So we can solve this problem in three different ways. Yes or no? The first one is we can solve this problem in a time complexity order of n. And secondly, like if you are writing inside the for loop that I is equal to 2, I less than root under n, where n is the input size, and I plus plus. Again, we are able to identify the time complexity. Means the same problem can be solved in order of root under n time. So what exactly we are doing over here? There are two different people who are solving the same problem in two different time complexity, out of which root under n is the optimal solution. So what exactly our next target is? Can we solve the same problem below the time complexity root under n, and how? That is the question always arise in the mind of every researcher. This is the very simple problem through which you people are familiar with, and that's why I have just given for example. So this is the algorithm that we basically write considering the operating system containing single CPU. Yes or no? So take some another problem like longest common subsequence problem. I hope if you are already familiar with the algorithm, then you know this particular problem, or very simple problem. Another problem we are considering, Fibonacci series. All of you are aware of this problem, I hope. So whenever you will try to identify the time complexity of the Fibonacci series in a recursive way, what will be the time complexity? See, I'm assuming you know this problem and you know the time complexity. That is the order of n. Yes or no? Order of n. So looking upon the behavior of recursive calls, what the people has started thinking that can we optimize the solution of this problem? And then the idea of dynamic programming came. Are you getting my point? So dynamic programming is nothing but if the same recursive calls or similar kind of recursive calls happening again and again, so we can go for the dynamic programming. So once you will follow my some another video lecture, you will be able to identify how with the help of dynamic programming we can solve the same problem for which the time complexity is order of 2 to the power n, which is exponential in nature. We can solve the similar problem in the time complexity order of n. So how we are able to do this, you can watch some another video lecture of mine or somewhere else in YouTube, not a problem at all. So dynamic programming is applicable for only certain set of problem. Just imagine there are infinite number of problems, or there are millions of problems, out of which we are only able to apply dynamic programming in 100 or 200 number of problems. So obviously this approach is not good in the field of computer science, but obviously we are accepting this approach because somehow this approach like help us to identify the time complexity or to optimize the time complexity for some of the problem. So definitely the idea is always respectful, yes or no? So always we respect the different idea in the field of computer science or in any other field. So what exactly we are observing over here in case of dynamic programming, if any problem is following certain nature in their recursive call, only then we can go for the dynamic programming, and every problem do not follow this, and that's why we are able to solve some of the problem. We are able to write dynamic programming algorithm for only some of the problem, and very limited number of problem can be solved. But still what about the remaining problem for which the time complexity is exponential in nature? Especially if you will look at the problem from the field of cryptography, all the problems take exponential time. Suppose you need to identify a key between two nodes who are communicating with each other. So just imagine if the key size is 128 bit. So how many keys are possible? 2 to the power 128. So for every key, if you will try to apply the brute force means you are applying each and every key to identify the correct key between the plain text and ciphertext. So in that situation, how many computation you will require? For each key you will require one computation. It means 2 to the power 128 computation you will require to identify the correct key, and which is, my dear friend, literally not possible by simple or in general, or you can say by classical computer. So I have added a new term over here, that is the classical computer that you are using in your day by day life, yes or no? So why we are not able to solve it by the classical computer? So that is again a part of simple analysis related with the operating system and the computation time for the single instruction by our operating system. So those are very simple things that I have already covered in my some other video lecture. Means if you will try to solve it, it will take 1000 years of time, which is not possible, yes or no? We always want the optimum time to solve a particular problem. So obviously we identify there are many problems for which we cannot write a dynamic programming, and that's why the people has migrated from dynamic programming to the parallelization of algorithm. So here the term parallelization of algorithm itself says what? If we are able to parallelize the problem, or you can say algorithm, then what we can do, we can compute the problem simultaneously if there are multiple CPU inside the system, yes or no? Just imagine you have a like 10 number of CPU in your system, and if you are able to parallelize your problem and feed it to the 10 number of CPUs, then what will happen? The same problem will be solved in minimum time, yes or no? Just imagine a simple example. Suppose there is a maze inside your college, okay, and there are 100 number of students, and there is a person who is serving the food inside the maze, and the person is taking 1 minute of time to serve the food to one student. So how many time it will take to serve 100 number of student? 100 minutes. So how you can optimize this time if you have a 10 person to serve the food in parallel? Are you getting my point? So if I will put over there 10 number of person to serve the food, and 10 person will simultaneously serve the food to 10 students in 1 minute, yes or no? So how much time will it take to serve 100 number of students? That is only 10 minutes. So I hope you are able to understand how we are able to reduce the time from 100 minute to 10 minute. The same thing is happening over there in case of parallelization of algorithm. So in case of parallelization of algorithm, what exactly we are doing, we are just making our code in parallel. Again, this is not very easy task, and please try to understand. Okay, this is not very easy task to parallelize the algorithm so that our operating system or whatever the device or whatever the software we are using, the device here we basically use name as GPU, graphical processing unit, and the coding that we basically do is the CUDA. CUDA is the programming language, and this is the device where we are trying to execute the problem in parallels. So you can execute the problem in parallel if and only if you are able to parallelize the sequence of code considering there are multiple CPU inside the system. So this is very interesting topic and very emerging technology. Most of the people are doing a lot of work in parallelization of algorithm, that is the GPU, and they are also doing the coding in CUDA. So the basic terms and condition to write a program in CUDA is the system follow SIMD. The system basically, the GPU system basically follow SIMD rule. What is the meaning of SIMD rule? Already you people have learned in architecture. Single instruction, multiple task. Sorry, single instruction, multiple data. Means there is a single instruction and you have a multiple data. And this single instruction will be applied to the multiple data. Just imagine you have a instruction addition and you have a multiple data. So what you can do, you can apply addition on the multiple data simultaneously with the help of GPU. So it always follow the rule SIMD, single instruction multiple data. It is based on that actually. Okay, so obviously if you are able to parallelize your problem, considering there are 1000 number of CPU inside your system, then what exactly you can do? You can optimize your time complexity. So for a problem where the single CPU is taking suppose 100 minutes of times, so if you will apply 100 number of CPU and you are able to parallelize that problem for the GPU, then what will happen? In single minute you can solve this problem. So for the same problem, single CPU system is taking 100 minutes and from the GPU it will be able to solve by 1 minute. So now hope you are able to understand how we are able to reduce the time complexity. So obviously my dear friends, in computer science all the fights are for time complexity, for optimization. So now it's time to quantum computing. So what exactly the quantum computing is? So my dear friends, again somehow for most of the problem for which we are able to parallelize, we can go for the parallelization of algorithm which can be solved by the GPU, and the programming language is CUDA. But still there exists a lot of problem for which even though we are able to apply parallelization of algorithm, we are not able to solve. Like there are many problems you can identify in the field of theoretical computer science as well as in the field of cryptography or in some another field where the problem cannot be even solved by the parallelization of algorithm. What exactly I mean that the problem is not solvable. See, a problem for which the time complexity is exponential. See, the exponential time complexity is quite very dangerous. What I am saying this term because if you will increase the size of input, even though you have a multiple processor inside your system, you cannot solve it in limited period of time. Please try to understand. I am giving some stress on this particular term. We cannot solve this in limited period of time. What exactly it means? The solving a problem will take years and years. It will take 1,000 years. So is this kind of solution useful? No. So definitely in that situation, we want some more powerful computing device, and that's why the people has migrated to new world, that is the quantum world. And that's why I have just given the name of this session as quantum world, and that can be solved by the quantum computing. See, the research is still going on. Some of the countries like like China and Japan, those are the country who are able to develop a small quantum computer. We cannot say that like very big quantum computer, but they are able to create a small quantum computer. So in case of quantum computer, means if we are migrating over here, our ultimate target is to solve a given problem in a limited time period. So I will give you an example. It is very interesting because it is not possible to like just tell you each and everything or solve a given problem give you the broad idea of the quantum computing in a single lecture. In fact, in a basic introductory lecture. So I will give you the example. Just don't worry. There are two things that we have to keep in your mind. What exactly the quantum computing is. So in case of quantum computing, there are two things which is happening. There are many things, but here I am focusing on the two things. First one, we are migrating from the real number world to the complex number world. That is the first thing you have to remember. From the I will correlate each and every terms later on mathematically. Just don't worry. Okay, so here the first term is we are migrating from the real world to the complex number world. That is the first thing. The second thing is we are migrating from single state to the superposition state. So what exactly the meaning of superposition state and the single state, I will give you an example. Just don't worry. So once you will be able to understand this particular example, this is quite interesting. So please go to the end. If you are able to understand these particular things, you will be able to understand what is the power of this quantum computing. I'm just giving you an example. See, explanation of or reason behind each and everything I will explain later on. Just don't worry. See, by single state system, okay, and what we are saying superposition state. Okay, so in single state system, suppose we are using 10 number of bits. We are using 10 number of bits. So or just you can just take some smaller example, that is the 3 bits. So in 3 bits, to store all the information of 3 bits, how much memory we will require? Just try to understand. 000, 001, 010 and so on, 111. So what is the size of memory over here? The size of memory is see, each block is taking 3 bits, and how many blocks are there? 8 blocks. The size of the memory will become 3 into 8 bits. Yes or no? So here what we are observing, at every state we are able to observe only one value. Yes or no? At every state we are able to observe only one value. So this is a particular state where the data we are able to capturing is 000. This is some another state where we are able to capture the data 010. So if you want to capture all the data, what will be the size of memory? The size of the memory is 3 into 8 bits. And my dear friends, if it is the n bit system, then what will be the total memory size? The total memory size will become n into 2 to the power n bits. Just try to imagine, suppose You want to develop a system where you require 100 number of bits. So what will be the size of system you will require? That is the 100 into 2 to the power 100 bits. Now you can imagine what exactly this size is indicating. Is it gigabyte, terabyte, or something else? Obviously you people know that 2 to the power 30 byte. What is this? If you are writing 2 to the power 10 bytes, so 2 to the power 10 bytes is equivalent to 1 MB, yes or no? And 2 to the power 30 bytes is equivalent to 1 GB. So if you are writing like 2 to the power 30, or in place of 2 to the power 30, if you are writing like something like 2 to the power 35 bytes, so what exactly it means? It is equivalent to 32 GB. So just imagine what exactly this particular thing is representing. Is it possible to create this size of memory inside the system? Just think about it. I am leaving these things to you. Later on, I will again repeat this kind of things. Okay, once I will start this subject and will make you feel what exactly the meaning of this smaller term is. Okay, so it is very hard to create this size of memory. And suppose for a given application, if you need this amount of memory, so it is not possible to solve that particular problem. Are you able to understand or not? So my dear friends, now we are coming to the next another kind of state, which is called the superposition state, and this term is basically used in quantum. Okay, so once I will start the quantum, I will make you like I will just tell you each and everything what exactly the superposition state is. Okay, what is the qubit, okay, what is the mathematics behind it, each and everything I will discuss. Okay, for the time being, our objective is to learn the beauty of quantum computing. Okay, so suppose in quantum computing, we don't say bit. In place of bit, we basically use the term qubits. So now just imagine 3 qubit system. 3 qubit system. 3 qubit system. There is a very small difference. In place of bit, what exactly the term we are using is qubit. The term that here basically we are using is the qubit. And what exactly the meaning of superposition state? Superposition state basically tells that all the states, whether there is like 0 0 0 0 0 1 0 1 0 and so on 1 1 1, all these states can happen simultaneously, simultaneously. So I know it's looking quite unbelievable, yes or no? You might have some question that, sir, how is it possible that all these states will appear simultaneously in 3 qubit system? So if you want to store all these state, then how much memory you will require? You will require only 3 qubit of memory, or you will only require 3 qubit system. In simple word, you can say. So rather than this, what we can do, we will require only n qubit system, or you can say n qubit. Are you getting my point or not? So n qubit state, if n is equal to 100, then with the help of only 100 qubit, we are able to store. Here we should not use the term store. We are able to like compute all these data. Are you able to understand or not? Since all these states are happening simultaneously, so what exactly we can do? We can check the computation by using all these data. Are you getting my point or not? See, here we are not storing the things. Please try to understand. Here we are not storing the things inside the memory. In this situation, if you want to store or use this kind of data, first of all you need to store this somewhere. And since in 100 qubit you can like in 100 qubit all the states are possible, or all the states are occurring simultaneously, so we can utilize each and every state to check our model, whatever you are designing, or you just feed those states to check your algorithm whether it is working or not. In a simple word, you can just say it. So what major difference here we are able to identify in bit system, like in a like classical system, you can say this is the classical model of computing. In classical model of computing, to store the 3-bit system or the n-bit system, you required n into 2 to the power n bit of memory. Okay, but in quantum system, to identify, okay, in quantum system here we cannot use the term store. What exactly we can use rather than store is, since all the states are happening simultaneously, so here we can utilize this property. Since all the states are happening simultaneously in superposition state, so we can utilize this property to solve our problem, the same problem which we are doing in a classical computing. So this is the major difference that we are able to identify over here. So I hope these things make you feel in some extent make you feel comfortable what is the reason and why the people has switched to the world of quantum computing. You are able to make a difference. So still, since we do not have any idea about the superposition state, like the classical state already we know, but we don't have an idea about the superposition state, what exactly the qubit is, how we can represent the qubit, and all those things. So once I will start the subject, I will go through each and every terminology that I have somehow some points I have used it, and the rest of the points I will use in future. Okay, so be with me for rest of the lecture, and hope you people will enjoy a lot this subject. And this subject is entirely based on your research work. Okay, so those who are studying this subject in your BTech, MTech or PhD, you can go through it, but this subject I will follow entirely for the research point of view. Okay, so thank you very much. अलविदा लेना चाहूंगा. Take care. मस्त रहिए. जय.